and welcome to another episode of FooBar. Sometimes we have more infrastructure resources than the one that AWS CloudFormation provides. It's quite common that we have a lot of resources that we consider part of our infrastructure that we need for our application or our architecture to work, and CloudFormation doesn't have a resource definition for it. So what we tend to do? Well, some cases we write a script in a paper or in an Excel file, and we put, okay, now we need to go to the console and, create a database and put this information in it with these properties. Or we need to run this bash script, or we need to even create a setup Lambda function. That's quite a use case I have seen lately, that a lot of people have Lambda functions that run their setup configuration. So whenever you deploy a stack, the first thing you do is to invoke this setup Lambda function. But those are really great solutions and they do their job. But if we go to the idea of infrastructure as code, they kind of belong there, but it kind of ruins the purpose of having this script that you can basically throw into any AWS account or in any region, and it will replicate the environment and everything you need. So in today's video, I want to talk about AWS CloudFormation Custom Resources. So AWS CloudFormation Custom Resources will solve all those problems that I mentioned. Everything can be represented as a CloudFormation resource, even though there is no definition for that particular resource provided by AWS. And you can do that by using CloudFormation resources. In this way, you can build your whole CloudFormation template with all these custom resources that are creating your database and configuring it, and using location map, location services that doesn't have CloudFormation support, or as you're going to see in the demo, recognition collection for faces, and all other things that might not be AWS infrastructure whatsoever. Create a new sandbox account in a third-party API you're using, or doing something on-premise even. It doesn't matter. But all of these can be attached as CloudFormation resources. So when you put the stack up, you deploy this CloudFormation resource, all these other things are also getting installed or getting run or whatever these custom resources are doing. And when you tear the stack down, you remove this CloudFormation stack, all those resources revert back to nothing. So custom resources basically enables you to write custom provisioning template or logic in the CloudFormation templates that will run anytime a stack creates, updates, or deletes. So these typical operations that we are going to do whenever we create a new stack, we run, CloudFormation deploy the stack, then the custom resource will deploy, then when we do an update, if it affects the custom resource, we can update it, or if we do a delete, we want to delete that custom resource, and it happens as well. There are many kinds of custom resources, so I want to focus on the Lambda-backed ones. And I think these are very, very powerful. So these are, I think, something I've been using now lately, and they're great. So basically, you will associate a Lambda function to a custom resource. So whenever the CloudFormation is deploying, for example, it will trigger the Lambda function automatically. So this is very close to this setup Lambda function that we have, that I mentioned at the beginning. That is quite a typical use case, that you have that Lambda function to create all the basic things that you need in your application, but CloudFormation doesn't provide. So now this is integrated into the deployment of the stack, and you don't need to remember to invoke that function. It will happen automatically. It will be invoked by CloudFormation. And also it will be invoked the other way around when you want to delete it. And that's very handy, because it happens quite often that you create a lot of custom resources with this setup scenario that you're launching, invoking the Lambda outside of CloudFormation, and then you first need to remove all these things that you created, and then you can remove your stack, or you remove your stack and you forget of all these other things that keep on hanging there. Lambda function is extremely powerful because it allows you to interact very well, very fast with other AWS resources. You can use the AWS SDK there super natively, so you can invoke basically anything. But you also can use third-party services or on-premise services by using HTTP connections. So that's what it makes it so powerful. In the demo today, I want to show you how to define CloudFormation Custom Resources using AWS CDK. I know it's very specific, but I've been going into CDK lately and I'm really enjoying it. And CDK has custom resource provider construct that is like a mini little framework that will be taking care of a lot of the things that custom providers need in order if you define them raw CloudFormation. So basically it takes care of a lot of the complexity of deploying and managing these custom providers. So before going to code, I will explain you what I want to do because it's easier. So I want to build a custom resource for creating a new face collection using recognition. So when you're using recognition to identify faces, you can store those faces in this recognition collection of faces. And then if you pop a face, it can search around. I'm making an interesting demo for you, but this is another video in the future. But the idea is you create this collection. So when I started building this application in CDK, I was like, well, I can create this setup Lambda, but why not to use a custom resource? Because this create collection is not an AWS CloudFormation resource. It's not available as a resource. So instead of that, I will be creating a Lambda function that is using the AWS SDK to create the collection. And also I will be using the AWS SDK to remove the collection. So when I do CDK Destroy, the collection is gone and I don't have random collections jumping around because we don't want that. So now we can go to the code. So as always, I will start with an empty project and I will be sharing the code with you in GitHub. So before jumping into the code, if you are here still watching, and you are about to use my code from GitHub and all that stuff, like this video, share this video, comment this video. We want people to get to know this channel, and that's the trick for making YouTube recommend my content. So now let's go to the code. So as always, I will be starting with an empty directory that we are going to create a new CDK application in it. Just to start from a clean slate, you can do this in any existing CDK application. So yeah, I will be using TypeScript. You can do this with whatever you like as always, but I'm a JavaScript developer, TypeScript, so it's easier for me. So let's wait for the application to get kind of downloaded and created. I will be then going into Visual Studio Code and showing you what to do there. So let's go to the code and start defining what we need. So we're going to our lib folder, and there in that stack, we are going to create our custom resource. We don't want to put it anywhere special. This is an empty project. So, well, if you're building a custom resource inside your stack, just figure out where you want to put it. So the first thing we are going to do is to install all the libraries we need. I'm pretty sure I will forget some library and we will need to install it later, but we need to install Lambda because that's something we are going to use. We need to install the custom resources because that's a library we are going to use. We need to install the logs because we are going to be talking about logs. At some point we are going to find some log retention policy. So that's something we need to install. And later on we will need IAM, but I think I forget to put it in this time and we will do it in a second. I will install it in a second. So when all the libraries are installed, now we can move to start writing the code. So the first thing I want to do is to define a constant that is the name of the collection. This is the recognition collection. I just put any name because this is for the demo. You can use basically any resource here to build. I just pick a recognition collection, face collection, because I was building this other demo and I like to reutilize stuff. Then we are going to create a new Lambda function, and this is going to call on event. You can put any name, but I like to make it align with the where this Lambda function is going to get called in the custom resource. So there we are going to put a name for it, recognition custom resource function, something small and simple. And then we are giving a runtime, no 14, because it's available now and we can use it. We can also set the handler, where the code is, and all that basic things from a Lambda function. So we have not yet built a handler, but there we will put the code that we need to create the collection using AWS SDK. You will see that it's very simple, and that's not the point of this video. So I will be storing all my functions in this functions directory, and I'm making the reference there, and I need to import the path library in order for this to work. Then we need to pass an environmental variable, that is this collection ID that we just created, because we will need that ID later in our code to create the collection with the name that we want. And then we can pass a role. Lambda functions are born without any permissions, no matter if they are custom resources. So we need to give permissions to the Lambda function to be able to create a collection in recognition. So we are just creating a new role, and I'm basically need to import IAM here in order for this to work. And after I import IAM, we can go back and do some definition of roles. So this is the role for the Lambda function, and I will be giving some policy to the role. So we will add to the role the capability of create a recognition collection, and then to anything in recognition, because we don't have any resources yet. So then I attach that role to my Lambda function, and then we can move on to start creating the custom resources. The first thing we are going to create is a provider, and this provider is this kind of mini framework that will be handling a lot of the managing of the custom resource. So here we will need to attach the Lambda function that will get triggered on an event. And an event means when the stack is deployed, updated, or deleted. So now I will be doing the same operation whenever, and you will see that it will fail on delete, and I will need to make some magic, but that comes later on the video. Also, if you have Lambda functions that are asynchronous, here you will have to do a callback function, so you can also attach that. In our case, we don't have an asynchronous call, but in some cases, your operations, your infrastructure might take more than 15 minutes to execute, and you might do it asynchronous. You might start the Lambda function and then leave it running, or invoke something, or blah, 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 and then you might need to have a callback operation, and you will define that here if you need so, and the provider will take care of that. Also, we are going to define the log retention. I will put it for 1 day, whatever you need, for this provider. So we get some logs if needed. And now we can basically add that provider as a custom resource, and we can have everything we need. The cool thing now is that if we want, we could have multiple instances of this provider that will be launching this Lambda 4 times. I don't know why, but who knows what your use case is. So they're all independent, and this is quite great. But yeah. So now let's create the custom resource and pass the a name for it. Again, recognition custom resource. And here, if you have multiple, just put different names. And then we need to put the service token, and this will be basically the ARNN of this provider, but there is an API for that. So with all that, then we have our custom resource created, and the mini framework that will manage the creation of that using CDK. So this is pretty neat. We need the code for the Lambda function before deploying. I always forget about this, so let's create that, and then we can see how this works in action. But don't go, because I want to show you also how to delete the stack, because I think that's important when you are building infrastructure as code. You want it to be easy to add and also be easy to destroy. So we will create the Lambda function, and in this case, we are creating a recognition collection using the AWS SDK, and basically we're just calling that, and that will create the collection for us. No big deal. So let's go on and deploy this into our AWS account. So for doing that, first we do npm run build to compile everything, and then we will do CDK deploy, and this will deploy the whole stack that only has one custom resource. Well, you will see that it has more things, but in our head, it only has one custom resource. And this will deploy everything into our AWS account. And let's fast forward in order for seeing what is the result. So now everything is deployed. Let's go to our AWS account into management console and see what we can see there in the CloudFormation stack. We open the CloudFormation service, and there we will see the last stack. If you just deploy that as last, is the name of the thing that you have deployed. If you go to the resources, you can see that there is a couple of Lambda functions and some custom resources and some permissions and things like that. So we can go to the Lambda function console to see what is going on there, and I think it will be a little bit easier to understand. So let's open Lambda and applications, and we go to the applications we just deploy, and there you will see that there is 2 Lambda functions, and you're like, why there are 2 Lambda functions? I just deployed one Lambda function that is the custom resource. What is this other Lambda function? Well, that's the provider, that mini framework that I was telling you that is in charge of handling all the lifecycle of your custom resource that CDK created for you. So if we go in there, we can see that there is a lot of code that we have not written. So this is CDK doing its thing. So that's what we love it. So we are not getting into there. And then if we go to the other function, you will see that the code you wrote, well, that I wrote, that you just copy paste. Or if you change it, it will be the code you wrote, the one creating the collection in our recognition. Good. Then we can use the AWS shell to check if our collection was created. I will be using the AWS CLI for that in the AWS Cloud Shell, and I will be running the list collection command to see if my collection, if this collection that I just created appears in the recognition collections that I have. So we can see that the demo custom resource is there, and basically our collection is listed. So what happens now with this code if we do CDK Destroy? It will explode. Yes, it will explode because our custom resource doesn't have anything. Basically, it's trying to create another collection with the same name, basically, on Destroy, because it doesn't have any way to know which event is on create or on delete. So I will remove everything magically. I will remove the collection, recognition phase collection using AWS CLI. I will be removing the stack, and we will start all over again. Well, not all over again. I will show you what you need to do in order to make the destroyed work. So the first thing you need to do in order to get the destroy to work is in your stack infrastructure, add another policy, another action to your policy that is the recognition delete collection, because we want that on the delete of the CloudFormation stack, the collection gets deleted as well. So good, we have that, we add that. And then what we want to do is in the code of our Lambda function to understand what is the event that is coming in. And that will be coming in the event object itself. So we know that Lambda functions, the event object of the Lambda functions depends on who invokes the Lambda function. In this case, is this custom resource provider that is invoking the Lambda function. And on the event, it will be basically sending a request type. And if the request type is of the type on create, well, in create, it will be creating the collection. We want the collection to be created. Good. But if the request type is delete, we want the collection to be deleted. And now we have that logic. We are building that logic. So whenever we do CDK destroy, then the request type will be delete, the collection will get deleted, and there will not be an error on the destroyed part. So let's fast forward and deploy this thing and see what happens. So we are deploying this thing again, and when it's deployed, we can go and check. So again, I list all my collections. As soon as this finished deploying, everything appears there. And now I will do CDK Destroy. Previously, it exploded, it failed dramatically, but now we will not have a fail. It will just execute lovely. And when it is finished, we can go to our CloudFormation stack and see that CloudFormation stack doesn't exist, so that's good. We can go and list all our collections, and you will see that collection that we created doesn't exist either. And this is what you want from infrastructure as code. You want it to be easy to tier up, to create, and also to tier down. So I love custom resources. I use them a lot. And I think now with this CDK integration is so easy to do them. The provider is so powerful. It does so much work for you. So I hope this video inspires you to try this thing out. So that's all I wanted to share with you today. If you have not liked this video, you just watched half an hour of content and didn't like my video, what are you waiting for? Go and like it. And let me know in the comments box below what other CDK content you would like to see. I know you are so into CDK content lately that I would love to build more about this. So let me know in the comment box below, and I see you in the next episode of FooBar.